Hello viewers, welcome to Diagnostics. Dio here. Today we have a 2016 Honda Pilot with a 3.5 liter. The complaint on this vehicle is that the check engine light remains on while the engine is running. So if the check engine light is remaining on while the engine is running, it means there is a problem in the engine management system. So what we're going to do is we're going to go inside the vehicle and connect a scan tool to the car. Once we get the scan tool connected, we will be able to retrieve the trouble codes in the engine computer. Once we get the trouble code, then based on the trouble code, we will know how we can fix what's causing the check engine light to remain on. So now let's go inside the vehicle and get the scan tool connected. I got the scan tool connected to the car. So now we're going to turn the key to the on position so that we can scan the car for some trouble codes. So right there, the key is on, so I'm gonna bring up our scan tool. So let's go to scanner. So right there, the scan tool has recognized the car, so everything looks good. Let's click OK. So we're gonna go straight to the engine computer because the check engine light is remaining on while the engine is running. So let's go to engine. Alright, so here guys, we have one trouble code in the engine computer. The trouble code is P219B, air fuel ratio variation of cylinder. So this trouble code is what's causing the check engine light to remain on while the engine is running. So right now what we need to do is we have to familiarize ourselves with this trouble code. We have to read about this trouble code. We have to know what causes this trouble code to be set. What I want to know is I want to know the code setting criteria. I want to know what happens or what causes the computer to set this trouble code. So we can go to service information, or we can just use a cool feature that the snap-on scanners have, which is called a troubleshooter. We can go in the troubleshooter and look up this code. But before we do that, I want to click on this diagnose button and see what we have here. So let's click on diagnose. This is the intelligent diagnostics side of the scan tool. As you can see, we have our trouble code over here. We got some top repairs, and the top repairs suggest replacing the injectors. It says replaced fuel injectors. So top repairs is the information that Snap-on gathers for us, okay? It gets this information from fellow technicians like me. So this tells me that when this trouble code set on a lot of these Hondas, the issue was fuel injectors. Okay, so replacing the fuel injectors fixed this. So this is good information to have. It's good to keep in the back of our minds, but we can't just replace components just based on what we have, right? We have to test things. So this is a direct injection engine. So this is good to know. I'm glad that I have this information available because now I know that this trouble code is caused by defective injectors. So now what I can do is I can go and test these injectors and see if I can find a faulty injector. Now let's scroll down over here, and the other good thing here is that there is no technical bulletin about this trouble code, so which is kind of good, but sometimes they don't list all the technical service bulletins over here. So let's scroll down and see if there's any other piece of information down over here. So let's go to real fixes. Sometimes there's good info here. As you can see, there's nothing. The data for the vehicle is not available, so let's back out of here. So this really doesn't tell me much. Let's back out of here, and I'm gonna stick to what I said. We have to look up this trouble code. We have to read up on it. I gotta know what the code setting criteria is. So right now I'm gonna go to the service information. Okay, so you can either go to service information. If you have a Snap-on scan tool, you can just go to troubleshooter. So I'll go to the troubleshooter in my case. So let's back out of here. Let's see if we have the troubleshooter available over here. So it looks like we don't have the troubleshooter here. So we're gonna have to go to the generic side of the scan tool so that we can look this code up in the troubleshooter. So let's go to the home tab. Let's exit out. Let's go to OBD Direct. diagnose. So let's go to display trouble code. All right, so right over here, here's our trouble code, P219B. We already saw this code already. And the good thing is, on the generic side of the scan tool, it tells us the bank where the problem is. So bank 2, FU ratio imbalance, okay? So this is good to know. I don't know if I already mentioned this. The owner of the vehicle is a do-it-yourself type of guy. He's really knowledgeable about vehicles. So when the check engine light came on, he connected his little code reader to the car to see what kind of trouble codes he had in memory. So he retrieved this trouble code, and what he did was he went to the local Honda dealership and got a FU ratio sensor. So he replaced the FU ratio sensor on bank 2. After replacing the sensor, 2 days later, the same code came back up. And I think he told me that he even took the vehicle to the Honda dealership to get the software updated. I don't know why he did that, but I don't know. Maybe they asked him to get the software of the engine computer updated. And I think a week later, the check engine light was still on. So we are here to get to the bottom of this. We got to figure out what's causing this trouble code to keep coming back. So let's back out of here. We're going to go to the troubleshooter. Remember, our code was P219B. So let's go to code tips, because right now we need to familiarize ourselves with this trouble code. So P21, let's find this trouble code, P219B. So here's our trouble code, P219B. So I'm going to click on it. And this is the description that we read in the codes menu. So bank 2 FU ratio imbalance. So let's read what it says. So the description here says, this fault code is stored when an error is detected with the FU ratio calculation. The mechanical condition of the engine and fuel system should be checked prior to any electrical fault finding. So this is really straightforward. Basically, we got to check the mechanical condition of the engine and fuel system first before we try finding any electrical fault, okay? And the possible causes are the ECM. So what may cause this trouble code to be set is a faulty ECM or a fuel pressure regulator, fuel pump injector, or mechanical defect. So these Hondas are known for having carbon on the fuel injectors, okay? Because this is a direct injection system. So these injectors usually get covered with carbon on the tip of the injector, which basically affect the way the injector sprays fuel in the combustion chamber. We remember on the top repairs on the intelligent diagnostics side of the scan tool, the top repairs recommended replacing the fuel injectors. So now what I want to do is I would like to test these injectors. I mean, these are direct injection injectors. I don't know if I can use maybe a lab scope and an amp clamp around the injectors just to see the amperage pattern and also the voltage pattern, and then we can compare the ones on bank 1 to the ones on bank 2. Let's see if we can do that, but let's see if there's a TSB for this trouble code. So let's back out of here and let's go to our service information. So let's go to share track and repair information. So this is a 2016 Honda Pilot. So let's see if there's a TSB about this. I think there is, because I've already heard of this trouble code. And usually when you have this trouble code, the issue ends up being the injectors. But I just want to be 100% sure that's what it needs before we replace them. Okay? So this is an Elite. Let's go to technical bulletins. So we're gonna go to engine control systems. Let's click there. So this is gonna give us a list of TSBs. So I don't know if you can see right over here. Warranty extension mil comes on with DTC P0420, P0430, P030X, and then there's and then it says and or P219A/9B. It says with software update. I think they already did the software update on this one. Here is our TSB. It says warranty extension. Mil comes on with DTC P0420/P0430 and then P030X. This is some misfire codes. And then P219A/9B. So this is our trouble code, and it says with software update. The software on this computer has already been updated on this engine computer. So this vehicle is definitely affected for this. Let's read what it says here on this background. So it says the PCM software may interpret sensor inputs as a deteriorated catalytic converter. Additionally, debris from the high pressure pump or the fuel injector machining process can cause internal wear or clog inside one or more injectors. One or more of the following DTCs may be stored. Oh, okay. So basically, a little bit of metal shavings can break in from the injectors or from the high pressure pump, and which can eventually clog up the injectors. That's good to know. And that can cause these trouble codes, this P0420, P0430, P300. I mean, we don't have misfire codes, but we do have these two trouble codes. And knowing that the air fuel ratio sensor has been replaced, the software update has been done. So this is starting to lead me towards defective injectors, guys. So let's see. Corrective action. Here it kind of tells us what to do. It says, do the following repairs depending on the stored DTC. If you have the P0420 or P0430 only, update the software and do the cylinder air fuel test. If the test fails, replace fuel injectors. Oh, okay. So basically you have to do the software update and do the cylinder air fuel test. If the test fails, then you replace the injectors. That's good to know. So then down here it says P0300 through P0306, P219A or P219B only, replace fuel injectors. So right over here. So see, if you only have this trouble code, you gotta replace the injectors. Okay, so this is a TSB from Honda. So that's good to know. I kind of feel comfortable with this information that I'm gathering. So right over here, this is definitely Honda stuff. I mean, knowing that they already did the software update and the air fuel ratio sensor has been replaced. So here it's just showing us the procedure of how to replace the injectors. So this here is the high pressure fuel pump. So this is the fuel pump between the heads. All right, so this is good to know, guys. So this trouble code can be caused by basically debris breaking in, metal shavings or debris breaking in from the injectors and eventually clogging the injectors. So that's why they're recommending replacing the injectors in this case. So I don't know if we can see that fault electrically, because if we use a lab scope, the lab scope will most likely just show us the electrical fault. I mean, a little bit of mechanical fault also. I mean, if the injector is opening or not, we could be able to see that in a waveform, but I don't know how visible that's going to be. So this is pretty valuable information right over here. I'm going to stick to what I'm reading over here. Okay, so this is pretty good. So now what I'm going to do is we're going to go under the hood and test these injectors. Okay, let's go under the hood and hook up. Hopefully we can get access to these electrical connectors. Then we're going to hook up the lab scope to the wires that go to the injectors. We will compare the injectors on bank 1 to the injectors on bank 2. So now let's go under the hood and test these injectors. Actually, before we go under the hood, let's look at the wiring diagram of this engine computer first. So let's go to engine performance. So let's see how these injectors are wired. Alright, so now we're gonna scroll down. We're gonna find the injectors on this wiring diagram. So let's click on the page over here. So I don't see any injectors on this page, so let's go on the next page. So I see 2 injectors over here. Let's zoom in on this page. So let's scroll down. So right over here we have 3 injectors. So we have injector 1, 2 and 3. So it looks like this over here is bank 1, because cylinder 1 is on this bank. So this is the bank against the firewall. Okay, so if we follow these wires, let's highlight these 2 wires. Let's see where these 2 wires go. Do they go to the engine computer, or is there some type of module that controls these injectors? So I just highlighted the 2 wires on injector number 3. I hope you can see that. So let's go to the next page, because these wires are going to my right, so they're going to the next page. So let's go to the next page and see where these wires go. The 2 wires from the previous page are still highlighted. So these 2 wires go to this blue box. So this looks like a control module. It says injector control module. So this control module controls the injectors. So what we're gonna do is we're gonna go under the hood and back probe the 2 wires that come from each injector. We're gonna look at the voltage waveform and the current waveform of each injector, because right now our problem is on bank 2. Remember that P219B trouble code is coming from bank 2. Apparently bank 1 is not bad, so bank 1 doesn't have a problem. Now let's go under the hood and test these injectors. Alright guys, we're here under the hood. As you can see, this engine is covered by so many covers. We have a lot of plastic covers here, so I'm gonna remove these plastic covers so that we can get access to the injector control module. So now let's do that. So this cover just pops off. So we're just gonna pop it off. So right there. So I'm gonna remove this. So now I'm gonna remove the engine cover. The engine cover also just pops up. So we just pull it out. So right there. Here comes the engine cover. So now I'm going to remove this air inlet tube. Alright, so here comes the air inlet tube. Alright guys, so I got all the engine covers removed, and right over here is the injector control module. So this module controls the fuel injectors and the fuel pump. So I got the cover of the injector control module removed. Right now I'm back probing 2 wires for injector number 4. Okay, so I'm back probing the wires that go to cylinder number 4 on the second bank, so the bank in front of the car. So right over here is our wiring diagram. So basically what I'm doing is, so this is bank 2 and right over here is bank 1. So injector 4 over here has 2 wires, so the green wire and the brown wire. So if you look over here on the control module, I'm back probing the green wire and the brown wire. Let me see if I can show you these wires that I'm back probing. So let's zoom in. So right over here I am back probing, so right there I'm back probing this brown wire and this green wire, and these 2 wires are going to cylinder number 4. Okay, so the electrical connectors that you see here on this control module, this connector here in the back goes to the back bank, and then the connector over here goes to the front bank. So right now what we're going to do is we're going to look at the voltage waveform for cylinder number 4, and then we will go on the next cylinder. So we're going to look at all the cylinders on bank 2, and then we will also look at the waveform for the cylinders on bank 1. Okay, so basically what I'm doing here is, let me show you on the screen what I'm doing. This is what I'm doing. We're gonna start checking this injector here first. So this is injector number 4, the injector on the 4th cylinder. So I'm back probing these 2 wires, but instead of back probing them at the injector, I'm back probing them at the injector control module. So we're gonna see the voltage waveform of the injector, and we're also gonna use our amp clamp and clamp it around one of these wires. We can either clamp it around the green wire or the brown wire. That will show us our amperage waveform. Okay, so once we read whatever we're gonna see here, whatever data we're gonna see on the lab scope, we will save it, and then we're gonna move down to the next cylinder, and then we're gonna go to bank 1. This is the bank that's next to the firewall. So we will compare the data we're gonna get from these injectors with the ones on bank 1. Okay, then after that we will replace the injectors. I just want to see the voltage waveform and the current waveform to see if there will be any discrepancy between these injectors. Okay, so now what we're gonna do is we are going to set up our amp clamp. I mean, I can't get to the injectors because the injectors are buried under the intake manifold. So now what I'm gonna do is I'm gonna connect my test leads first. It doesn't really matter which one goes where at this point. Okay, so my yellow lead is going to the brown wire, and then my green lead is gonna go to the green wire. Okay, so, and the other thing I'm gonna do is, let me see if I have enough room here. I'm gonna clamp my amp clamp around one of these wires. So I'll get the amp clamp clamped, and then I'll bring you guys back up. Alright, so I got my amp clamp clamped around the green wire. So now let's set up our lab scope. Let's go to scope multimeter. Let's go to a 4-channel lab scope. Okay, so let's adjust our voltage scales first. So this is a direct injection injector. So these injectors actually spike very high voltage. So let's go up to 100 volts. So channel 1 and channel 2 are going to the injector wires, and then the 3rd channel is going to be our amp clamp. So we can adjust our time base a little bit later as we go. So now the lab scope is set up. So now I'm gonna go inside the vehicle and start it. I'm sorry for the noise in the background. So everybody's in the shop right now and we're all working, so it's a little bit noisy. I apologize. So we do have 3 traces on the lab scope. So the blue trace is our current waveform. The green and the yellow trace are our voltage waveform. So right around this area, the injector gets turned on, so current starts to flow, and up around the peak over here, the injector is turned off. Okay, as you can see right over here, there is a descending slope, so around here current stops flowing. Okay, electrically everything looks just fine, but these direct injection injectors can get clogged up with carbon. So now we're gonna move down to the next injector. Okay, so I want to take a picture of this capture. Okay, so we're just gonna save this and we're gonna compare it. So we're gonna compare it with the other injector. Okay, so I'm gonna go inside the vehicle, I'll turn off the engine, and then we will back probe the other cylinder. So I'll go inside the vehicle and turn off the engine. Alright, so I turned off the engine. Let's remove this amp clamp. Let me see if I can get this amp clamp removed. So that's removed. Let's remove these back probing tools. Okay, so we're still on this connector. Okay, so let me see if I can hold this light up here. So the two wires we're gonna back probe will be the blue wire, this wire over here, the blue wire, so the solid blue, and the blue and red tracer. So these two wires are what we're gonna back probe. So right there. So now I'm gonna connect my test lead to these two back probing tools. Okay, so right now we're gonna test cylinder number 6. So let's go to scope multimeter. So we have the same setup. I'm gonna go inside the vehicle and start the car. Alright guys, so the engine is running. Now we're testing cylinder number 6. As you can see, there isn't a big difference from what we just saw. Okay, so our current waveform looks pretty decent. Our voltage waveform looks decent as well. So the peak on the voltage waveform, so the green trace, the peak is 197 volt. Okay, and these are direct injection injectors, so these injectors spike a high voltage. And right now this waveform looks the same. It looks the same as the one we just saw. Okay, our amperage here on the max with 9 amps maximum on this injector. I mean, there isn't a huge difference from what we just saw. Let's just look at the picture that I just saved. Okay, so this is what I just saved, and as you can see, it looks basically the same right over here. This is the screenshot that I just took of that injector, the number 4 injector. Okay, this looks, look at this one, and let's go back to our lab scope. Look at that, see? It's the same. So these injectors are fine electrically. These injectors are known to have carbon built on the tip of the injector. We can go down the line and test the other injector. I mean, at this point, I feel comfortable replacing the injectors. I'm gonna go to the back bank, the bank over here, bank 1. We're just gonna test one injector, and then we're gonna compare it to what we're seeing on bank 2. So let's do that now. I'm gonna turn off the engine, and then we will test one injector on bank 1. Now we're gonna do one last test before we remove these injectors. So now we are on bank 2. Now we're gonna back probe one of the injectors on bank 1 just to compare it to what we just saw. So let's go to our wiring diagram. So this is bank 1 over here, and the wires for cylinder number 2 are the blue and red trace, and then solid blue. And then cylinder number 3 is the one with the green wire and the brown wire. So cylinder 3 is green and brown. So as I'm looking at my connector over here, on this connector, okay, so green and brown are just right over here. So we're gonna back probe these two wires for cylinder number 3. Okay, so let me do that right now. So we're gonna back probe this wire over here, and then we're gonna back probe the green wire. So I'm doing this just to compare the voltage waveform of the injectors we just tested and one of the injectors on bank 1. So we got this connected. Let's connect this one. Okay, so I'm gonna find a way to clamp my amp clamp around this brown wire, and then we'll see what kind of waveform we're gonna get on the lab scope screen. So I'll get this amp clamp wrapped around the brown wire, and then I'll bring you guys back up. Alright guys, so I got the amp clamp wrapped around the brown wire. So now I'm gonna go inside the vehicle and start the engine. Let's go to scope multimeter. So right over here guys, this voltage waveform and the current waveform looks exactly as the one we saw on the injectors on bank 2. So remember, our fault code was on bank 2. The fault code was 219B, and when we went to the generic side of the scan tool, it told us that that was on bank 2. And we did a little bit of reading about that trouble code. What the TSB suggested that we replace the injectors. The injectors look good right now, so they're all working. I mean, electrically, I don't really see a problem on these injectors. Okay, so let me put this over here. My scan tool is starting to get hot. All right, so this looks good. I mean, if we compare this, I'm sorry for the glare, guys. If we compare this waveform here that we have, if we compare it to the picture that we just saved, it will look the same. Let's go to our data manager, and right over here. So this is the waveform that we got from one of the injectors on bank 2. Okay, and if we go back to our lab scope, so we're gonna compare what we just saw to the injector over here, and this is one injector on bank 1, and as you can see, they all look the same. The only slight difference is, you see how we have a lot of movement here on the yellow trace. Let me turn off the green trace. You see over here, okay, this looks like a turbulence over here. We didn't have a lot of it on the picture that I saved. Let's look at that one more time. So let's see. So on this picture, you see over here, we didn't have a lot of turbulence. There's a little bit, but not as much. Not as much as we have on the other injector. I don't know if that makes a big difference. Okay, so I'm gonna go with what the TSB suggested. Okay, the TSB recommends replacing the injectors. I mean, the injectors are definitely getting the control. There's power, there's control, there's current flow. So these injectors are defective, especially the ones on bank 2. Okay, so this air fuel ratio sensor over here had been replaced at some point, and the customer also told me that the computer software had been updated in the past. So we're gonna go ahead and replace these injectors. So everything looks good on our lab scope screen. These injectors are not defective electrically. I believe there's a lot of carbon built up around the tip of the injectors, and these direct injection engines are really known for that. They usually have a lot of carbon built up on the tip of the injector. So I'm gonna turn off the engine, and then we'll get these injectors replaced. So I'll go inside the vehicle and turn off the engine. Alright, so the engine is off. I'm going to let the engine cool down a little bit. I'm gonna remove all these tools I have over here in the engine bay. Once the engine cools down, and then we'll start taking stuff apart. Okay, So we're gonna replace these injectors. So I will let the engine cool down a little bit and then I'll bring you guys back up. Alright guys, so I got the engine cooled down. So now we're gonna replace the injectors. So the engine is pretty cool right now. Replacing the injectors on this engine is pretty straightforward. We're gonna have to remove the intake manifold. Once we remove the upper part of the intake manifold, then we're gonna remove the bottom part of the intake manifold, and then the injectors will be right there. Removing this intake manifold is pretty straightforward. This intake manifold has 6 bolts. So 1, 2, 3, 4, 5, 6. So once we remove all these 6 bolts, then we're gonna disconnect this PCV tube. We're also gonna disconnect this brake booster hose, and we're gonna remove this EGR tube. After removing this EGR tube, we're gonna disconnect the air duct tube, and I'm gonna disconnect the map sensor also. After we disconnect the map sensor, then our intake manifold will come out. Actually, the throttle is got coolant lines going to it, so I'm not gonna disconnect these coolant lines. I'm just gonna undo the throttle and just lay it down over here. So I'm gonna remove the throttle from the intake manifold, so I'm just gonna lay it down, and then the intake manifold is gonna come out. This is really straightforward, so it doesn't take much. I'm gonna sit you guys over here so that we can remove the intake manifold. So let's do that.